We are in Precalculus. We're on homework 3-9. There's the title. Let's jump in. The whole idea of this lesson in homework is you have this x that's trapped. It's trapped in the exponent. There's no way to get it down unless we use a logarithm. The logarithm is the tool that kind of unlocks the power to get this x out of the exponent. And I'll show you how to do that. So I'm going to take the log of both sides. If I take the log of the left side and the log of the right side, I'm going to fill in the inside. This is 4 to the power of x in here and 11 in here. You're allowed to take the logarithm of any base that you want. In fact, I need to have some room in here so I can write my base. I can choose any base, and typically speaking, the best base to choose is the one where I could choose a base of 11 and these would cancel out. But if I choose a base of 4, these would cancel out. And you try to make the side that the x is on as simple as possible in the general sense. I don't think it matters. I think this way is just typically easier. I might be wrong. But I'm going to choose a base of 4 because I know that it's going to make these 4s over here on the left cancel out. I'm going to cancel, 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 and x is going to be by itself. Again, I'm going to show all of my work on number 1, and then I'm going to go a little bit faster on the future problems. But the idea here is that this x is going to come down in front. So I'm now going to have x times log base 4 of 4. And then on this side, it's still going to be log base 4 of 11. And again, you think of the log function as what power does 4 need to be raised to get 4? Well, 4 needs to be raised to the power of 1 to get 4. So this entire thing evaluates to just 1. And I'll go ahead and cross that off as well. I'll say this entire thing all gets crossed off and it goes to 1, which means on the left-hand side, I simply have an x. On the right-hand side, I don't want to keep writing log base 4 of 11 because you'll notice on the left-hand side, when I go to the functions, there's no log base 4. I would need like so many buttons for log base 3, log base 2, or maybe a function button that can do all of that. And I'll tell you the truth, I don't like lying to you guys. The more advanced calculator that you have, they will have this, but on most calculators, they don't have it. So that's the reason I'm teaching you. Most calculators don't have this, so here's how you do it on most calculators. You do the change of base formula. You do a log of any base. I'm going to do log base 10, which means I'm not going to write the base on the top, and I'm going to do a log on the bottom. And again, I just have to choose where does the 11 go, where does the 4 go. 11 is, you can see it's higher up than the 4, and the 4 is lower down than the 11. So 4 comes down here, 11 goes up here. I should probably do that in ink. So I have 11 on the top, 4 on the bottom, and I'm done. There's the answer. So I can come over to my calculator and I can say, okay, what is log of 11? And then this is all going to be divided by, and then I go back to function, log of 4. And it says that this is equal to, and again, I'm approximating a little bit, so I'm going to do my little approximately equal to sign, which is like a squiggly equal to sign. This is 1.7297, and that's rounding to 4 decimal places. So there's the answer that we're looking for, and I can check my answers on the back. 1.7297, 1.7297. There it is. So we're doing it correct. Let's jump into number 2. So a little bit faster this time, shall we? All right, so in this case, I'm going to take the log base 15. Ooh, my 15 looked weird. Log base 15 of this side over here, and I'm taking log base 15 of this side as well. And I'll rewrite the original 33.8 and rewrite the original 15 to the power of k. And going kind of fast as I promised, all of this cancels out, leaving us with whatever's up here, and that's just a k. Sometimes there will be more stuff. Like in number 3, there will be a k plus 1 left over. In this case, I just have a k. On the right-hand side, I'm going to do a change of base formula all at the same time. So I'm going to have a fraction of logs. I have a log of 33.8, and I have in the bottom of the fraction, the denominator of the fraction to be technically correct is log of 15, and then I can punch this into the calculator. So here we go. We have log of 33.8, and that's all going to be divided by log of 15. And I get, ooh, that came out to, I have to round up, don't I? 1.3000. Because all of that had to round up. So I'm guessing the back, the answer key is just going to say 1.3. Usually the zeros, yeah, they don't write the zeros here, but I like to show that I know that I'm rounding to the correct answer. So got that one right. Let's move on to number 3. Okay, they get slightly more tricky, but it's the same general concept. So in this case, I'm going to take the logarithm both sides. So I'm going to take log, guess what base it is? It's going to be base 2 because we have a base of 2 right here. So I'm going to have log base 2 of this I'll write this in black, 2 to the power of k plus 1, and that is going to be equal to the same log with the same base of now 26. All right, and as before, cancel, 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 leaving us with k plus 1 on the left, and on the right side we are going to do a change of base formula, and we're going to get log of 26 all over log of 2. And then from here, I just need to subtract 1 on both sides. -1, -1, and there's my final answer. K is going to be approximately equal to, I'm just going to write all of that in the calculator. So here we go. We have log of 26 divided by, that's not the button I wanted to hit. Oh, I have to backspace a bunch of times. Log of 2, and then after that, I subtract 1. And I get 3.7004, rounding to 4 decimal places. Let's check the back. 3.7004. 3.7004. We're doing it right. All right. Here we go. Number 4. This is the first time where we need to isolate the exponent. So this is the exponential function. This is not the exponential function. This is annoying, this -3. We need to get rid of it first. We have to isolate the exponential function. So I'm not going to say +3. You guys know I'm going to add 3 to both sides. I'm saying that out loud. So I get 18p is equal to, if I add 3, this is going to turn into, 67. I just added 3. And then from there, I'm going to do that same process. I'm going to take the log of both sides. So I'm going to say log of all of that 18p is equal to, and I should choose the base right now, shouldn't I? It's going to be log base 18 of 18 to the power of p is equal to log, again, base 18 of that 67, which I'll write there in the blue. So it's 18p and 67. And then what's going to cancel? Cancel, cancel, cancel. This is going to be p by itself, and we're going to go ahead and say that is equal to, change of base formula, ready, set, go, log of 67, all of that divided by log of 18. Let's go ahead and approximately equal to, so squiggly equal to sign, and we get the following. We get log of 67, and that's going to be divided by log of 18, and I get 1.4547. 7 doesn't get rounded up because it's followed by 2, so that should be the final answer. 1.4547. 1.4547. Excellent. All right. Starting to approach the medium territory. All of these problems I would consider intermediate. Again, number 15, you need to get rid of this pesky +2. It's not part of the exponential. So we're going to add 2 to both sides to get just a 14 to the power of 9, and is equal to, if I add 2 to that, it's going to be 97. And then from here, I'm going to take the log of both sides. So I'm going to say log base 14, because our base is 14, of that inside is going to be equal to log base 14 of the 97. We'll write that in now. 97 and 14 to the power of 9n. All right, so what cancels? U and U cancel, leaving us with just 9n. And on the right side, I'm going to do my change of base formula, meaning I have a log of 97, oops, that's not a 7, 97 divided by a log of 14. And you've guessed it, we need to divide both sides by 9. So divide by 9, which means I just put another 9 in the bottom here, and we are solved for n. So this is going to be about what? Punch you into the calculator. So I'm going to say log of 97, and that's going to be divided by 9. Ooh, I have to type in the 9 first. 9, and then log of 14. 14. And I get 0.1926, and that 6 does not get rounded up because it's followed by a 0. So 0.1926. 0.1926. Hooray! We're getting them right. Well, I should celebrate my failures more. Eventually, I'll make a mistake, and then I'll be really happy. All right, number 6. Is there anything that's not part of the exponential? No, everything there is trapped in the exponential. There's no step I can do to isolate it anymore, so I need to immediately take the logarithm. So I'm going to take log base 7 of all of that inside, give some room, and that's going to be log base 7 of that inside, that 14.2. So let's write down the 14.2, and this 7 to the power of 4m plus 1. All right, what cancels? U, and U cancel, leaving us with a 4m plus 1. On the left, change of base formula on the right, and this is going to be log of 14.2 in the numerator and log of 7 in the denominator. Now we have 2 additional steps. I'm first going to need to get rid of this plus 1, so I'm going to subtract 1, and then after that, I will divide by 4. So after that, I'm going to divide by 4. So there's 2 ways to do that. You could do it and make it messy and say, everything there is divided by 4. Yeah, you could. I want to divide each piece by 4, and that's also okay. I can say 4 there and 4 there, and that's also the same thing. So I think that's how I'm going to write my answer, and that will get the 1 and 4 are gone, so I just get m by itself. I am going really fast now, and I assume that we're in Precalculus, so it's okay for me to make these tricks. If you have questions after watching this video, I first apologize. That's the whole reason that you're here, so I can explain it to you. But if this is still not making sense, please ask me in class tomorrow and I can slow down. All right, so I'm going to just type that all into the calculator. Ready, set, log of 14.2, and then that's going to be divided by 4 log of 7, and then after that, I have to subtract 1/4, minus 1/4. And I get approximately, so squiggly equal to sign, 0.090, not 8, it gets rounded up to a 9, 0909. That's interesting. It's kind of a cool little pattern. All right, number 6, 0909, there it is, 0909. Number 7. Oh, we're getting even harder. I mean, number 9 and number 10 are like really the hardest questions. So we're not quite there yet. Let's try number 7. So I need to isolate the exponential. Right now, 3 to the power of p is the exponential. This pesky minus 6 and this pesky 5 are in the way. Reverse order of operations tells me I'm first going to deal with this minus 6. So I'm going to add 6 to both sides. So I'm going to get 5 times 3 to the power of p. After I add the 6 is gone. 6 plus 36 is 42. And then from there, I'll divide by 5. So after dividing by 5, I'm going to get 3 to the power of p by itself, and this is going to be, I don't know, 42 divided by 5. I'm not going to actually calculate that. I'm just going to leave it as a fraction because I'm lazy. Mathematicians are lazy in nature. All right. From here, the p is trapped up in the exponent. There's only one tool that can save our, what's that Disney princess? Rapunzel. Rapunzel can only get down with a logarithm. So let's do the logarithm of both sides. We're going to do the log base 3 of whatever is on the inside and log base 3 of whatever is on the inside there. What was on the inside? Well, it was a 3 to the power of p and a 42 divided by 5. So what cancels? U, and U cancel, meaning that p is by itself, and we do need to do a change of base formula. So we're going to have a fraction where the numerator is log of 42 over 5 and the denominator is log of 3. So type all that in, approximately equal to, calculator, go. We have a log of a fraction is going to be 42 divided by 5, and that's all going to be divided by another logarithm, and that logarithm is just 3. And we get 1.937. That 1 gets rounded up because it's followed by a 9, so it turns into a 2. So 1.9372. Let's check. 1.9372, we got it right. One of these days I'll make a mistake. I'm just too good, too cool for school, man. All right, what am I noticing for number 8? Well, I'm noticing that this is the exponential. You are not the exponential. You pesky minus 10 need to go away. Notice it's being multiplied, so I'm going to divide by negative 10 to get rid of it. After I divide by negative 10, I'm left with 6 to the power of 1 minus 2m just by itself. On this left-hand side, you just move the decimal place. It's negative 6.3. That's how you divide by 10 or multiply by 10. You just move the decimal place to the left or the right, depending on what you're doing. All right, so from now, I have Rapunzel trapped in the tower. This exponential needs to come down. The only way to do that is by taking the logarithm of both sides. I'm going to take log base 6 on the left of whatever is on the inside and take the log base 6 of whatever there is on the inside. So I have 6 to the power of 1 minus 2m and negative 6.3. All right, what cancels? U, and U cancel, meaning I have a 1 minus 2m left over. Right side, change a base formula. I mean, you've seen this over and over again. It's the same procedure, basically, over and over. The only thing that really changes in these problems is what do you have to do to isolate the exponential function, and what do you have to do after you're done with that? Like, there's a few tiny little twists. So from here, I said change a base formula. Get back on track, Mr. Sindel. We have a log of negative 6.3 in the numerator and a log of 6 in the denominator. Once I do that, you'll notice that I'll have to do what? I'll have to get rid of that 1, so I'll subtract 1 on both sides. So let me do that right now. I'm going to subtract 1 as a separate step. Maybe that's going to be red. I'm going to subtract 1, and what has happened now is this 1 is now disappeared. I just have this negative 2m. Well, to get rid of this negative 2, I'm going to divide everything by negative 2. And just like I did in the previous problem, I could say everything divided by negative 2. That works, but it's not stylish. It doesn't look cool. Here's what looks cool. You want to put a negative 2 in both of these. And you'll notice here, I have a negative over a negative, which is really a positive. So I'm just going to go ahead and say that's a plus a half, and that will be the same thing. So what is that? And that, by the way, I've isolated for m, and I've gotten rid of those 2 terms. So that's how I'm showing my work. I would like to do multiple steps over and over, but I'm kind of running out of room. So that's why I'm kind of cheating and writing it all in one line. What are you? Well, calculator, tell me, what are you? You are, in the numerator, we are log of negative 6.3, which is undefined. Wait a second. Did I make a mistake? Yes, I did. Okay, if you caught it up before here, you can pause the video and try to find it. All right, now that you've unpaused the video, the mistake was here. I said that a negative divided by a negative was a negative. That's not true at all, because otherwise this is unsolvable. And it is solvable in this case. I have a feeling that most of these are solvable, but I don't think ever on a quiz or a test or homework check I will try to trick you. So they should all be solvable. I knew I made a mistake once I saw undefined on the calculator. This should have been a positive, so that is my mistake. If you caught it, log the extra credit point, and I will erase you, sir, and erase you, and erase you, and now we're all correct. It's a little bit off center, but that's okay. So I'm going to go ahead and type 6.3. And then this is all going to be divided by, and we have a negative 2 log of 6, and then after that we add a half, so plus a half. And you can't see the half, but I promise it's there. We got this answer, which I'll write down right now. It is negative 0.0136. Okay, does that 1 get rounded up? Oh wait, the 6. The 6 does not get rounded up because it's followed by 1. So there's our final answer, negative 0.0136. Negative 0.0136. Excellent. Well, I haven't made a mistake. I made a mistake, so I'm kind of happy that I made that. But I haven't really learned too much aside from be careful with your division, Mr. Sindel, when you're not showing as much work as you typically do. Wow, number 9 has a lot of steps. So what I'm seeing by glancing at this is the exponential. You don't belong and you don't belong. We need to get rid of them. Reverse order of operations means we have to get rid of the subtraction first and then the multiplication. So I'm going to add 7 to both sides, and that's going to give me a new function. I'm going to get negative 3 times 4 to the power of negative 7x. That minus 7 is now gone because we've added 7 to both sides, and negative 48 plus 7 is a negative 41 because you're adding. So adding and subtracting are opposite signs, so you're really subtracting the 7 and taking the sign of the larger. All right, anyway, from there, we are now going to get rid of this pesky negative 3 by dividing both sides by negative 3. So when I do that, I now have a 4 to the power of 7x, and on the right side, a negative divided by negative is a positive. I'm not making that mistake twice in this unit, or this, maybe in this unit, but not on this homework assignment at least. And I get a positive 41 over a positive 3. But Mr. Snell, it was a negative over negative. Okay, fine, it's a negative over negative, but a negative divided by negative is a positive. All right, so now we need to untrap our Rapunzel, untrap our exponent, bring you down. The tool that we have isn't Rapunzel's hair, it is a logarithm. So we're going to take the log of both sides, and I'm going to get log what base? Base 4, of course. Base 4 of 4 to the power of 7x. And that's going to be equal to log base 4 of that fraction, 41 thirds. By the way, 41 is not divisible by 3, and as a quick reminder, 4 plus 1, if I add the digits, 4 plus 1 is 5, and 5 is not divisible by 3. Therefore, 41 is not divisible by 3. What cancels out? Well, check out that left side. You, and you are gone, meaning only a 7x is left over. From the right side, I need to do a change of base formula, meaning I have a log of 41 thirds in the numerator and a log of 4 in the denominator. And then from there, I just need to divide both sides by 7. So divide by 7, put the 7 down there, and we are in good shape. So I just need to type u in, and I will get an approximation. Ready, set, function. We get a logarithm of this fraction 41 thirds, and that's all going to be divided by the function logarithm Oh, nope, I want a 7 first, don't I? 7, and then logarithm of 4. And we get, I'll write down 0.2321. That 1 does not get rounded up because it's followed by a 0. Did I write that down right? It looks right. All right, 0.2321. 2321? Dun, dun, dun. I've made a mistake. All right, finally I can be excited. I am officially excited, guys. I have made a mistake. And I don't know what it is. I should have got a negative answer. What did I do wrong? And let's go ahead and see in here. Oh, that's such a dumb mistake. Okay, whatever. There's extra credit up there. Pause the video now so you officially get the extra credit. If you're too lazy and you're just going to hear it from me, it doesn't count. You see it? You see it? There it is. It was right here. What have I done? I had a negative 7x and it turned into a positive 7x magically? No, it has to say a negative 7x, Mr. Sindel. All right, cool. So that's like a real mistake that I didn't know until the very end, right? Did I know? Well, I guess I knew this one close to the end. So that should have been a negative, which means that should have been a negative, which means that should have been a negative, which means that should have been a negative. And all I have to do is come back over here and in front of the 7 put a negative. No, look, now it's a negative 0.2321, and it's still wrong. It's still wrong. What have we done? All right, there's 2 mistakes. Oh man, there's so much extra credit in this video. Because notice, it's not 2321, it's 2695. All right, let's look back through our work. This is the fun part. What did we do wrong? All right, so this is how I think about mistakes. If I add, maybe it was that very first step. If I add 7, adding and subtracting are opposite signs, which means you subtract. 8 minus 7 is 1. You take the sign larger. Okay, so negative 41, that looks good. Did I copy everything down there? Good. Yeah, okay. Then I divided by negative 3, so I see the negative 3 down there. Everything looks fine and dandy. The negative over negative is a positive over positive. Everything's copied down. Okay, I took the logarithm base 4 because that was a base of 4. Everything looks good there. That all does cancel out, meaning I have just a negative 7x left over here. Log base 4 because it matches that base 4 and it's still the same number. I copied that down correct. I have log of 41, log of 4 because 4 goes on the bottom, 41 over 3 goes on the top. The negative 7 went down here. I feel like everything is entered correctly. Did I type it in the calculator wrong? Ooh, I don't see it. Oh my God. I did enter in the calculator wrong. Well, that's an easy extra credit point to fun. Okay, if you found it before I just did, you can get it. But I wrote 5 there, and I should have wrote 4. Hey, that's the right answer. It took a long time, but that's how you think about your mistakes. You go through every single step, and you look for it. All right, we have a negative 0.269, and then that 4 gets rounded up to a 5 because it's followed by a 7. So I think that's the answer on the back. If not, now I'm going to get kind of frustrated. Negative 0.2695, 0.2695. Whew, there it is. All right, number 10. All right, I've made my mistake for the day, but I can still learn more. I kind of don't want to make any more mistakes. We'll see what happens now. I want this video to be over. Okay, who doesn't belong? You don't belong and you don't belong. I just want the exponential function. You are the exponential function, but you are not and you are not. Get rid of the 9 first, then get rid of the 7. Here we go. All right, subtract 9 on both sides, and I'm left with 7 times 17. I was about to write 3. 2 minus 7k. The 9 is gone because we subtracted 9. And on the right-hand side, 11 minus 9 is 2. So 11.6 minus 9 is 2.6. All right, now I need to get rid of that 7. I'm going to divide both sides by 7. And I just get a 17 to the power of 2 minus 7k. And on the right side, I get that 2.6 divided by 7, whatever that is. All right, now that I've done that, I'm going to take the logarithm of both sides. I'm going to take the logarithm of what base? Well, the base that is the base of our exponential function, of course. It's going to be a 17. And this is rewriting on the inside here in red, 17 to the power of 2 minus 7k. And I also have an equal to sign with a log of the same base, still 17, of all of that inside, which is a 2.6 over 7. So 2.6 over 7. All right. Who cancels out? You cancel out, you cancel out, you cancel out. Everyone cancels out except for 2 minus 7k. And on the right side, let's do a change of base formula. So we get a log base 10 of 2.6 over 7, and that's all divided by log of the base, which used to be a 17. All right, few last steps here. We need to get rid of this 2 first, order of operations. Get rid of the 2, then get rid of the negative 7. Get rid of the 2 by subtracting 2. That's pretty straightforward. So if I subtract 2, that's a bad minus sign. Minus 2, done. So you're gone. Okay, now I have this pesky negative 7 in front of the k. Negative 7 is being multiplied by the k, so I'm going to divide both sides by negative 7. And as I typically do, I'm going to divide each individual piece by negative 7. So you get a negative 7 and you get a negative 7, which means a negative divided by negative is really a positive. And I think that's the right answer. So let's go ahead and check that off. I mean, I thought the last one was the right answer too, didn't I? But here we go. This is approximately equal to, type it all in, ready, set, logarithm of this fraction 2.6 divided by 7, and then that thing is going to be divided by a negative 7 times a logarithm of 17, and then that is going to be added to 2/7. And I get 0.3357. Okay, I'm secretly actually hoping to make a mistake. I kind of want to learn, but let's see. 0.3357. 335. Okay, I got it. Whatever. It happens. It happens that I'm good at math. I might have done this a few times. Anyway, there's the entire homework, 3-9 for Precalculus. Hopefully you learned something. I'll see you guys later. Bite in box's answer. Bye.